Good morning, Algebra 1. Today's lesson is the very first chapter in chapter 3, which starts off with the fun and the awesome literal equations. Now, literal equations are actually fairly simple, and a lot of the techniques that we're going to use you already know and you're familiar with. You're just not used to using them in this manner. So if you just remember that you already have these techniques in your mind, then this actually will probably be fairly simple. But don't worry, if it's not, you'll get plenty of practice and you'll learn it by test day. All right, so let's first talk about what are literal equations. Well, literal equations contained several variables, all right? And we know that a variable is an unknown number. So let's say, for instance, I came up with this equation. X plus y equals 10, all right? That is an equation. We have two unknown variables, several variables, right? And it's equal to something. In this case, it's equal to 10. Okay, now, so we have satisfied this first portion of our requirements for a literal equation. Now, in a literal equation, we solve for one variable. Alrighty, so let's say that I have this same exact problem, which is x plus y. Yes, that's a plus, not a t. So x plus y equals 10, and the directions, which is me, tells you to solve for x. Well, first things first, I know that this guy needs to stay put. Anything else that is not him needs to move to the other side of the equal sign. Alrighty, so this is plus y. Well, how do I move a plus y? Of course, I do the inverse, which means I subtract y from both sides. These two cancel out, and I'm left with x equals 10 minus y. Well, guess what? I just solved for x. Solving for a variable just means, literally, get that variable alone. Alrighty, set it aside, put it by itself. Okay, so now, let's practice this a little bit with two easy formulas. Now, these are two area formulas, and it's specifically for a rectangle, okay? Remember, it's the same exact formula. We just use two different variables. For instance, this one says A equals B times H, which is base times height. And this is area equals length times width. It's the same thing. If I was looking at a rectangle, just look a little quick. No, there we go. Beautiful rectangle. If I was looking at a rectangle and I wanted to label the base and the height, I would say, well, this is base and that is the height, right? And so in that case, I would use those numbers, whether this was, let's say that was 3 and this was 2, I would put 3 times 2, and then A would equal 6. Alright, you remember that. Alrighty, the same goes if I actually want to use the length times the width. Just like this is a base, I can call that the length. And just like this is the height, I can call that the width, right? And you remember that in rectangles, I should say, it doesn't really matter which one you call the length or the width. Now, sometimes it will, but in most cases, you call this one length, that one width, this one width, that one length. And in the case of a rectangle, it always seems to work out. All right, so now, why would I care about solving for a specific variable? Let me talk about that before we actually do this. Let's say that I gave you this following information. Here's my rectangle, and let's pretend that I told you that the area of the rectangle equals 50. Okay, and that this side right here equaled, let's say 5. All right, now you probably can look at the answer and kind of look at the problem and figure out what the answer is. But let's just pretend like you can't. All right, so if I were to plug this into my formula, this information into my formula, I would say A. Now the A is 50, so 50. Whoops, got a little glitch. Let's see if we can fix that. There we go. I would say 50 equals, now remember, you can either say base or height, doesn't matter. I'm just going to keep this. I always put my base down at the bottom. That's just me. And this is my height. Height normally goes from the top to the bottom, so in this case, this would be height. All right, so 5, so a base times 5. Ooh. So here comes the question. How do I solve that? Well, now, if I know how to do a literal equation, I could set this guy up, right, so that my b is already on the outside, and what I need to do to the numbers is on the right side or the inside. All right, so now let me demonstrate that to you first. All right. I hope you have your pencils and paper. I hope you're writing this down. All right, so if I need to solve for b, okay, that means that this b right here needs to somehow move over to that side. All right, but now notice that this operation right here is a multiplication. How do I separate these two? How do I get rid of them? Well, that's easy. The opposite or the inverse of multiplication is division. So if I need to separate the b, I need him to stay exactly where he is. He's not moving anywhere. The h needs to leave. Those two cancel out. Notice, see, I divided by h. I go on this side and I divide by h. And what am I left with? I'm left with b equals a divided by h. Now, if you're like some people, seeing an equation in this direction bugs you, and I must admit, I'm kind of one of those people too. So in this case, I could just, flip it around. B equals a divided by h. Okay? But notice, they're exactly the same, right? Same. And they're going to work out the same. So now, I can now plug in my numbers. Now let's watch this. So if I say b equals the area divided by the height, that means that b would equal the area 50 divided by the height of 5, which means b equals 10. Alrighty? That's simple, isn't it? It would work the same way if we did it for area equals length times width. Alright, so now let's try another one. Oh, gorgeous, gorgeous. What is this guy? Yes, it is a perimeter formula. A perimeter formula for a rectangle. We have P equals 2 times length plus 2 times the width. Alrighty, and they tell us in the directions to solve for L. Alright, this one's going to take a little finagling, but we can do it. Now, first things first. Number 1, locate your variable. Locate variable. Now remember, he stays put. Don't move him. Don't move him unless he needs to be moved. And in this case, sometimes it's more advantageous to move him, but I'll show you what to do. Alright, so here's the variable. Let's leave him alone. He stays put, okay? Now, the second thing that we need to remember is that everything else moves to the other side. I know it's a long direction. You can shorten it any way you like. Alright, so who needs to move? Well, this 2w needs to move, and eventually this 2 needs to move. Alright, so now it's just same thing. When we do our formulas, we always go for, let's just move this guy, right? No division necessary. Let's just move him. He's easy. So plus 2w, we're going to subtract 2w on each side. Subtract 2w. And what we're going to have is we're going to have p minus 2w. See? P. Oops, there we go. P. Oh, got a little glitch again. Don't worry, it won't stop me. Alright, p minus 2w equals, and of course those two cancel, equals 2 times L. Alright, so do you follow me so far? If you don't, pause, rewind, start over. Okay? Now, again, who needs to move? This 2 needs to move. This L needs to stay right where he is. So what is the operation between this 2 and the L? Well, the operation is multiplication. The inverse is, bam, division. So I'm going to divide by 2 because we know that L stays the same or stays in the same place. That cancels out. Divide this whole thing by 2. Right now, let me tell you this first things first. Okay, remember these are literal equations. Because we don't know what the W equals, because we don't know what the L equals, we don't know what the P equals, we can't solve this. So don't start going and crossing out the 2's and, trying to do all that fancy. No, 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 no. Remember, you're just rearranging. It's just like in your room. If you were in your bedroom and you wanted to rearrange your dresser and your chairs and your bed and your nightstand and your lamp, you wouldn't necessarily get rid of anything. You just want to move them around. That's what we're doing. We're just moving them around. So now, back to what I was saying. So these two cancel out. We divide this side by 2. And we are left with P minus 2W. Oops. Oh, goodness. Pen is having a spasm again. All right. All right, so P minus 2W divided by 2 equals, I seem to have gotten rid of my equal sign. There we go. Equals L. Now, like I said, if you're one of those spastic people like I am and that just bugs you, flip it around. Put the L on the left side and put this whole thing on the right side. So P minus 2W. Let's just keep on rolling. 2, there we go. Ooh. Divided by 2. Alrighty, that's not too bad, right? Now, let's go and review or should I say, yeah, it's kind of review or visit a familiar friend. Alright, so I want to talk to you about the distributive property. Now, we already know the distributive property. We have fought with the distributive property, but we have won. Alright, so let's look at this. It says A times 4 plus 7. And remember, when we're using the distributive property, we take the A and distribute it to each number inside or each variable inside the parentheses. So I have A times 4, A times 4, which I could just write it 4 times A, right? We could just flip it around, commutative property, plus A times 7, which is the same as saying 7 times A. Alrighty. Now, what I wanted to show you about this is that I can go from this right here and come up with that right there. Let me give you an example. Let's go back to that original problem. P equals, there we go, 2 times length plus 2 times width. Now, in this case, you notice that, well, let me ask you this question. What does this term, the 2 times the length, what is this term? Let me use a different color. So what does this term and that term have in common? Ah, yes, the number 2. Good. So that means I can take this 2 and that 2 and pull it out. All right, so I'm literally going to be undistributing. I'm going to be taking it away. All right, so I'm taking that 2 away. And that leaves me with an L and a W. And what sign is that? Plus. So guess what? Bam. There we go. So do you see how I went from, first we go from distributing it and then working it out to having the answer and then separating it basically. All right, so remember, the first thing to do with a distributive property like this, when you need to go from multiple terms and to kind of bring it down, or what's the word I'm looking for, or consolidate it or make it in a more simplified form, look for what they have in common. This guy was a 2. This one had a 2. Well, who do we pull out? The 2, okay, because they both have a 2. Who stays inside the parentheses? Well, the L and the W. In this case, look, I had an A and an A. Those 2 A's were pulled out. What was left? The 4 and the 7. And of course, the sign in the center is the sign that is in the problem. So notice plus, 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 plus. All right, so now you say, okay, Ms. Bragg, what you doing? What you doing? Well, what am I doing? Yay! We're going to work this beauty out. All righty, and then I will set you on your way. So let's just look at it. Let's read it first things first. We have A times X minus 5 times B equals 7 times X plus 18 times B. Ooh, beautiful. And we need to solve it for X. Okay, so here we go. Step 1. Step 1, you should be saying it to yourselves that you work it out. Step 1, we need to find our variables. Okay, the guy that we're solving for. So I'm going to solve for this one, and I'm going to solve for this one. All right, so those are my two x's in that case. Now, I need to get them on the same side. Considering that I like having my problems where the guy I'm solving for is on the left side. You know how we like to have that x equals 10, right? I like to have my x, since I'm solving for him, on the left side. I'm just going to go ahead and I'm going to move him to that side. All right, so he's a positive 7x. So we know the inverse of positive is subtract. There you go. So subtract 7x, subtract 7x. All right, so I'm going to rewrite. I'm not going to be lazy. Don't be lazy. And I'm going to have a times x minus 7 times x minus 5 times b equals, those two canceled out, equals a positive 18 times b. Whew, that's a beauty. All right, so now I have my x's on the same side. That's good. But you see this guy, he is a nobody, and he needs to move. Alrighty, so how do I get rid of a negative 5 times b? Well, that's easy. Opposite of subtraction is addition. Add 5 times b, add 5 times b. I'm left with a, oh boy, there we go. I'm left with a times x minus 7 times x equals 18. 18, there we go. 18 times b plus 5 times b. There we go. Now, I don't know if you've noticed it, because I've noticed it. Do you see these two have the same variable? I can kind of just add those together, can't I? So what is 18 plus 5? Well, that's 23. 20, yes, that's a 2. 3b, okay? So notice I'm just doing a little combining. This one is going to, problems like these just take all of your brain power. And that's a good thing because we learn this to practice it. If you don't practice it, you lose it. Now, here we come to the fancy part. Well, you say, well, Miss Braggs, this is an A. That's a 7. I can't combine it like I did to 23. Well, if you notice, did you notice that they both have something in common? This one has an X. That one has an X. Guess what? That means distributive property because I can't have two X's. I have to move the 7. I have to move the A. And the fastest way of doing it without actually kind of getting confused, right, is to just use the distributive property, right? Because if I move that 7x over, it's not going to do anything for me. So here we go. Watch what we do. So if this is an X, they both have X's, I'm going to pull out the X, set up a parenthesis, right? I'm going to take this first variable, the A, he goes inside. The second variable, 7, goes inside. What sign is that? That's subtract, so there we go. We have just used the distributive property. And then, of course, bring the rest of the problem down. Now, here we go, last step. Do you see it? What are we solving for again? X, okay. Is the X by himself? No. What is the final step? To move all of this over here, leaving the X by himself. Well, let's read this correctly. It says X times A minus 7. Did you hear it? It said times. So guess what we're going to do? We are going to divide. That's the inverse, right? X times A minus 7, inverse, divide. Divide by what? Well, we're going to take that whole A minus 7 away. Just get rid of them. Divide by A minus 7, which leaves us, these cancel out, X equals 23 times B divided by A minus 7. Whew. How do you feel? I know I feel good. All right, so that is how we do literal equations. Alrighty, now remember the key thing, okay? The key thing is first and foremost, do not panic. These problems are simple. Remember, you are not solving necessarily, meaning that you're not getting a number answer. You're just rearranging. If you can read the equations correctly, it automatically tells you what to do. Remember, in this case, we had area equals base times height. Well, how do you separate them? Inverse of times divide, right? And as long as you know who you're solving for, in this case, we solved for B, right? As long as you know who needs to move, you can do it, okay? So what you're going to do is you're going to go ahead and do the pages that are associated with this lesson, alrighty, which the sub has for you, and you're going to do well. If at any point you just can't figure it out, you're of course welcome to watch this video again, and I will send you another one for tomorrow. Have a wonderful, wonderful day. Alrighty, bye-bye.